Hi, everyone, I am Wei Huang, a student from University of Science and Technology of China. I would like to introduce our work titled, Style Projected Clustering for Domain Generalized Semantic Segmentation. Domain Generalized Semantic Segmentation aims to better predict pixel-level semantic labels on multiple unseen target domains while learning only on the source domain. Existing semantic segmentation methods improve generalization capability by regularizing various images to a canonical feature space. While this process contributes to generalization, it weakens the representation inevitably. In contrast to existing methods, we instead utilize the difference between images to build a better representation space, where the distinct style features are extracted and stored as the basis of representation. Then, the generalization to unseen image styles is achieved by projecting features to this known space. This is overall framework of our proposed method, which consists of two components, namely, style projection and semantic clustering. With the development of deep learning, segmentation methods based on supervised learning have made significant progress in multiple semantic segmentation tasks. However, once these methods are deployed in real scenarios, their performance will sharply decrease due to the distribution discrepancy between real scenarios and training datasets. Domain adaptation is an effective solution, which leverages the unlabeled target data to improve the generalization of models on the specific target scene. Although domain adaptation methods have to some extent improve the generalization ability of the model, this generalization ability can only be reflected in one or several fixed scenarios, rather than multiple different scenarios. Domain generalization is a more effective solution, which does not rely on any unlabeled data from multiple scenarios during the training phase. In addition, it aims to improve the robustness of models to arbitrary unseen scenarios. Therefore, domain generalization is a more challenging and practical solution, especially for semantic segmentation. There are two kinds of domain generalization methods, namely style augmentation, and instance normalization and instance whitening. First, style augmentation adopts style transfer algorithms to transfer the style of natural images to the training dataset, which enriches the style of the training datasets and improve the robustness of models on natural images. However, there are still distribution discrepancies between the migrated style and the real scenarios. In addition, it still cannot cover all the real scenarios. Second, instance normalization and whitening regularize image features from different domains to a canonical space, which aims to capture the domain-invariant characteristics of object contents, and eliminates the domain-specific ones, namely image styles. However, it is difficult to perfectly decouple the style and content information. In addition, the content information is often also eliminated simultaneously, which weakens the representation ability of features. Different from these two kinds of methods, we propose a novel style projected clustering method for domain generalized semantic segmentation, to represent unseen images based on the known data. Our motivation is the following 2 points. First, we expect to use the existing training datasets to represent the image style in the unknown scene. This not only does not require style expansion of the training datasets, but also preserves the style information of the training data. Second, we expect to use clustering operations to achieve semantic classification of pixels according to the idea of the nearest neighbor algorithm. This not only preserves the semantic information of the training data, but also has better generalization than the learnable classifier. The overview of our framework is shown here. Our framework consists of two components, namely style projection and semantic clustering. First, in the shallow layer of the network, we realize the style representation of the unknown image, through the weighted combination of the style bases of the training datasets. Second, in the deep layer of the network, we realize the pixel clustering of the unknown image, by calculating the distance between the semantic bases of the training datasets. In the style projection, we first extract the style information of the input image, that is, the mean and variance of the shallow features of the network. Second, we calculate the similarity between the input image style and the style bases. Third, we use the calculated similarity as the weight coefficient to carry out the weighted combination of style bases. Finally, we inject the weighted combination of style bases into normalized features and achieves the representation of unknown style. In the semantic clustering, we first calculate the similarity between each pixel vector and semantic bases. Then, we select the nearest semantic base as the category of each pixel. During the training process, we adopt 3 kinds of loss functions to supervise the training of the network, including 1 pixel-wise cross-entropy loss, 1 clustering loss, and 1 contrastive loss. We evaluate our framework on 5 representative urban datasets, including 2 synthetic datasets and 3 real-world datasets from different cities. We conduct experiments on 3 different settings, including single source, 2 sources and 3 sources. In addition, we adopt mIoU as our segmentation metric. As shown in these tables, our domain generalization segmentation method achieves consistent advantages in 3 different settings, which fully demonstrates the superior generalization of the proposed method on multiple different target datasets. As shown in this figure, we can find that our method generates better segmentation results on 3 different target datasets, which again demonstrates the superiority of the proposed method. We further conduct distribution analysis by the TSNE visualization to demonstrate the effectiveness of the proposed method. As shown in this figure, we can find that the style distribution of different domains is well separated before style projection, while their style distribution is approximately constrained between 2 style bases after style projection, which demonstrates style projection successfully projects unseen styles into the style representation space built on style bases. As shown in the figure, we can find that pixel samples belonging to the same class are well clustered while those belonging to different classes are well separated. In addition, the preserved semantic bases are approximately located in the cluster center of pixel samples. In addition, we can find that these pixel samples from different domains are well clustered according to their classes, which demonstrates our semantic clustering successfully achieves the class prediction between different domains. In this paper, we propose a novel style projected clustering method for domain generalized semantic segmentation, which achieves the style and semantic representation of unseen images based on known data. In particular, style projection projects arbitrary unseen styles into the style representation space of source domains and achieves the retention of specific style information between different domains. Semantic clustering predicts the class of each pixel by the minimal similarity distance to semantic basis, which realizes the semantic representation for unseen images and promotes the generalization ability. Through the evaluation on multiple urban scene datasets, we demonstrate the superior generalization performance of our proposed method over existing domain generalized semantic segmentation methods. My presentation ends here. Thank you for your listening.